Hello.
Hello? Hello?
जी मैम।
Hello?
जी मैम, निकलिए।
Nikhil, you have to be louder.
यस मैम, सॉरी।
Can't hear nothing. No one can hear anything. यार मेरा वो कहाँ से निकालना पड़ेगा? The background, it is still coming of the previous one.
ओके मैम, आपको लाइक स्टार्ट वीडियो में जाना है।
Start video.
यस मैम।
नहीं नहीं. When I put that background has to go, no?
मैम लाइक इन स्टार्ट वीडियो यू हैव टू चूज वर्चुअल बैकग्राउंड।
Then none, no?
हाँ।
Blur. ठीक है. I think blur is okay, I guess. Or none is okay. None is okay. So, you informed our students?
यस मैम, आई हैव लाइक रिमाइंडेड देम इन द ग्रुप ओनली।
एक बार सीआर को फोन लगाना. So Divya is there?
नॉट नाउ मैम, आई हैव शेयर्ड द लिंक। हेलो सर, यू आर म्यूटेड सर।
Hello, everybody. Hello, Dr. Nilima. From Kunal.
Sir, good morning.
Good morning.
How are you?
Oh, very good.
1 second, sir. I'm just coming. Huh?
Yeah.
Sir, good morning. How are you?
Doing very well, madam. How are
Yeah,
you?
Sir, I'm good too. So,
Right. Nice.
so Monica is here. She's my student. She works here also in Prestige Engineering College.
Hello, Monica.
Kunal yet to
Yes, sir.
join.
Good morning, sir.
Good morning.
Actually, Kunal is in Italy at present.
Oh, I see.
So,
So thank you very much for organizing this.
no, it's a
event.
very important lecture actually. Because you know that BIS test methods also, I think this is under revision, right? So
Yes, it is under revision. In fact,
so-
myself, Sanjay Gupta, and others are members of the code committee. We have been working on it. In fact, IGS, on behalf of IGS under Professor Samaria, also we had sent some recommendations to BIS, and
Yes,
most
yes.
of the recommendations are being incorporated.
Hmm.
So the draft code is ready. So they should be circulating it very soon. And
True,
it will
true.
and
Yeah,
it
I
will be
was told
adopted.
by BIS Umang because when we had some other discussion, so this is actually very important basically to all the people who are in the industry. So I hope like
Uh-huh.
our MP problem with the Indore is like we don't have a good labs at present.
I understand. Yeah. Hello, Dr. Sarvesh
Sir,
Chandra.
good morning. Sir, it's so nice that you joined. Thank you so much.
I'm greatly honored, sir, that you have joined.
Sir, we are not able to hear you.
Sir, you are muted.
Dr. AP,
Hello,
good
Dr.
morning.
AP Singh. Yeah.
Sir, very good morning.
Good morning. Great
How
to
are you,
see
sir?
you. Oh, I'm fine. How about you?
I'm fine, sir. Your blessings.
Oh, no.
Yeah. Very nice to see you today. Yeah.
Thank you. Thank you.
Good morning, Ravi Sundaram
Sir,
ji.
good morning.
Good morning.
Neelima.
Good morning,
Good
How are
sir.
you, sir? It's been
Yeah,
long
fine.
time.
Good morning. Yeah. Okay.
Sir, greatly honored that you have joined today.
No. I keep learning from all of you every time. No?
Sir, you have been the guru to everybody.
Yeah, exactly. No doubt.
Learning must never stop. That's what I believe.
Yeah.
Okay, good luck.
Sir, we'll wait for a couple of minutes, but the people may
Yeah.
keep joining, but we'll start
Yeah,
because the
yeah,
thing is
that's
like we are
okay.
recording.
Uh-huh.
Just want to inform you before because this year all the events, because we are celebrating our 75th year of IGS also, so we are
Yes.
trying to record all the things and putting in our YouTube. So it will
Yeah.
also help
Oh, that
people
will
to
be
go
good.
back and see. So first of all,
That
I
will-
should take your consent for recording also.
Of course, sure. And please do send me the YouTube link also.
Yeah, sir. I request all of you to join this YouTube channel. It is already circulated on the mail also. On
Yeah,
by the
we have to
IGS. Yeah.
subscribe, but
Yeah. You have to
IGS,
subscribe. Yeah.
IGS YouTube channel, is it? Okay.
Yeah.
yes,
It is
yes,
there.
yes.
Yeah,
And
okay.
you know, the last events, like whatever I have done with Indo-Italy workshop and then 5 days event with Professor Krishna Reddy, I think all these lectures have been already there, hosted by IGS office.
Dr. AP Singh, you have been doing a lot of very good work. International exposure to IGS has been tremendous.
Thank you,
Started
sir, for
Started
encouraging
with
us.
Nepal and then the Korea, Japanese, everything is fantastic.
Thank you, sir. We are all encouraged by you people. What you have taught us, trained us, that's what we are putting forward.
No, sir. So Professor S.K. Prasad, he'll be joining too.
Oh, great.
So when the draft guidelines are being prepared, so how long they will keep it to make it like a code? What is the standard timeline with the BIS?
Actually, BIS has no standard timeline. It's a very inefficient organization. But the normal, this thing is they circulate it and then they give 1 month time for, people to give comments.
So this SPT thing, is it in test methods or it's in the guidelines?
See, actually 2131, in that they have included the energy measurement right now is optional because as you know, currently very few companies are having it, and you don't want to suddenly paralyze the geotechnical investigation activities in the country. So the idea is to make it popular, and maybe the next version it will become mandatory.
Okay.
And
So when
hopefully
are we
that the next
expecting the
version,
next version then?
hopefully the next version should come in another 5 years. But as you know, that the current version 1981, it's been too many years. So more than 40 years. So I hope it won't take another 40 years to bring this in. The general mandate for BIS is to review the codes every 5 years, and if any changes are required, they are supposed to incorporate. But it has been happening so slowly, and then of course we always had the now we have the excuse of COVID, which stopped things for 2 years. But people did learn this online connection only during the COVID, so that was one of the plus points.
Okay, sir, we'll start.
All
Hope
right.
that is okay, right? The other people may keep joining us. So first of all, good morning, everyone, and welcome to this monthly lecture series of IIT Indore IGS student chapter, which we started in 2018 January. Since then, our students have been doing really very active role in taking this kind of activities, especially from the practicing consultants of the Indian infrastructure industry. So we have a lot of good lectures, and since IGS is celebrating this 75th year, so we have been trying to do more rigorous activities. So with this a very short intro, I would like to thank Ravi Sundaram sir for immediately accepting to give this particular talk, which is very, very crucial or important in the present investigation scenario in the country where we are having huge amount of infrastructure coming up. So thank you so much, sir. And I also welcome our secretary, honorary secretary, Dr. A.P. Singh, our very senior faculty teacher, Professor Sarvesh Chandra, sir, for joining today's lecture. So thank you so much for joining. It's always happy to meet you virtually or on phone call, etc. So with this introduction, it's my pleasure to introduce Ravi Sundaram sir today. So he's a founder director of Cengrs Geotechnics Private Limited, which is in Delhi, and he directs the company's geotechnical consultancy services and geotechnical construction activities. He started his career in USA and worked at the company's office in Saudi Arabia. He has extensive experience outside the country as well, UK and other countries. His expertise includes geotechnical investigation, geophysical surveys, ground improvement, and groundwater studies. He has been involved in developing engineering solutions to problems of foundations under artisan conditions and collapsible dune sands, soft clays, expansive soils. I think he has worked on all types of soils and others, whatever the associated hazards. His special interests include foundations for tall buildings, thermal and solar plants, bridge foundations, as well as testing of pile foundations and strengthening of the weak or distressed foundations. He has published over around 70 papers, and he is very active publishing, whatever the case studies are from his industry experience. He always published with IGC and Indian Geotechnical Journal. So, sir, it's very with my pleasure. So it will be very happy to listen to this particular topic, because I've been involved with many people, but this is one of the very, very crucial thing that should go as a kind of awareness to every stakeholders in the industry and also in the academia. So thank you so much. With this brief introduction, so I stay over to you, sir.
Thank you, Dr. Nilima, for that very kind introduction. Without further delay, I will now share my screen and present can you see my screen?
Yes, sir.
Yes, yes.
Is it now on presentation mode?
Yeah.
Yes.
So I would be greatly honored to make this presentation on energy measurement to standardize SPT. I am really grateful to IGS chapter at Indore, IIT Indore student chapter, and the Geohazards lab in IIT Indore for inviting me to make this presentation. All that I am presenting here is based on my experience with conducting SPT and making energy measurements over the past so many years. So I will try to share some of my experiences with you. So the contents of this presentation, I start with the history of the standard penetration test, details of the test, the equipments, the codes and factors affecting the values, etc. Correlations based on SPT values, need for various corrections to SPT, hammer efficiency measurement device, what is the equipment that is used, and what is the final outcome of the measurements that you do. I will also be presenting 2 case studies demonstrating the benefits of energy measurements and enhancement of reliability in the foundation design. So as you know, the SPT is the most popular and commonly used penetration test. A geotechnical investigation, most people understand boreholes, SPT, that's it. So this is the most frequently used subsurface exploration test performed worldwide. It is not just India, but worldwide. SPT is the most popularly used test. The greatest merit of the test and the main reason for its widespread use, that it is simple and easy to perform, and it is very inexpensive. So because the cost factor, you can see that it's so it is doesn't cost much, so it is very popular. It's an in situ penetration test. It provides data that has been correlated by various authors to various geotechnical properties of the soil. But unfortunately, it's also the most misused and abused test. Despite its many flaws, it is usual practice to correlate SPT results with the soil properties for the relevant aspects of the geotechnical design. Now, a little bit about history. The SPT is over about 120 years old. So in 1902, Charles Gow of Gow Associates and Gow Construction in Boston, he used a 1-inch diameter sampler driven by a 110-pound hammer. In the mid-20s, a split spoon sampler was introduced by Sprague and Henwood of Pennsylvania, and they used samplers of diameters ranging from 2 inches to 3.5 inches. In the late 1920s and early 30s, Harry Moore of Raymond Concrete, he standardized the procedure. In 1927, again, Gow used a 2-inch diameter split spoon sampler. He recorded the blows to drive 12 inches using a 140-pound hammer with a 30-inch draw. Most geotechnical agencies and experts in US and other countries did not like this kind of system which he proposed. It was not very popular, but Carl Terzaghi, he liked it. And once the father of geotechnical engineering liked it, and then he encouraged it and it became quite popular. In 1938, ASC's committee meeting, Terzaghi and Arthur Casagrande vigorously sponsored the adoption of the split spoon sampling procedure. So you can see Gow here and of course Carl Terzaghi. In 1940, the work of this committee was carried out by at Harvard University by Horslev, and then the SPT was standardized. In 1947, Terzaghi proposed the concept of standard blow counts to estimate soil properties. He and Harry Moore, they developed correlations between allowable bearing pressure and NSPT in sands. In 1947, at the 7th International Conference on Soil Mechanics and Foundation Engineering, Terzaghi renamed the procedure standardized by Raymond Concrete Company as the standard penetration test. Very interesting side story here is that this 7th International Conference was attended from India by two eminent people at that time. There's Mr. Arora from Railways and Dr. Gulhati. Both of them were inspired by Terzaghi, and they came back to India in 1948, 75 years back. They started the Indian Geotechnical Society. At that time, it was called as the Indian Society for Soil Mechanics and Foundation Engineering. In 1948, Terzaghi and Peck published the first SPT correlations. So that's the background of how the SPT evolved over the years. In 1958, ASTM adopted the SPT and published the standard ASTM D 1586. The current issue, of course, is 2011. In 1963, the Bureau of Indian Standards adopted SPT and issued the code IS 2131. Current issue is 1981. It has been reaffirmed in 2002. The code is now under review. Again, it was reaffirmed in 2021. Now, of course, the code is under review and revision and is likely to be published very soon. Industry leaders recognize the importance of measuring energy transfer during the standard penetration test to standardize the test and to eliminate the uncertainties. IGS Executive Committee has sent its recommendations on this code, including the energy correction and all that. Hopefully, it should be out very soon. So let's just get a background of the standard penetration test, how it has been done. So as you are all aware, you have a split spoon sampler. Is there some issue? Have I been muted?
No, you are audible.
Okay. So there is a hammer 63.5 kg weight that is basically converted from 140 pounds. There is a cat head. This rope, it falls by a height of 750 mm or 30 inches. So you drive by 45 centimeter, record the blows for every 15 centimeter. So you record it in 3 steps. The first 15 centimeter is ignored because of the possibility of loose soils or cuttings. The cumulative number of blows for the last 30 centimeter is called the N value. You all know that. Yeah, so this is the SPT being conducted. You record every 6 inches or 15 centimeter penetrations, and of course the last 2 are the combined to calculate the N value. So this is the split spoon sampler ASTM standard, and this is the IS code 9640. This is what you have, the split spoon. So once you do the sampling with the SPT, whatever you collect from the split spoon sampler, what you recover is a representative disturbed sample. It is suitable for classification tests like grain size distribution, Atterberg limits, specific gravity, etc. Not suitable, of course, for properties which measure the in situ soil structure, like density, moisture content, shear strength characteristics, consolidation behavior, and all. You cannot test with these samples because it's a disturbed sample. Now let us look at the values which are factors which are affecting the SPT. Number 1, whether the method of hammer release, whether it is manual or whether it is automatic. Particularly if you have a manual hammer, each blow, the height of fall may not be exactly the same. And particularly in hot summers, you may find people working more efficiently right in the morning, but as the sun goes up and it's very hot, the height of fall may reduce, and the control may not be very efficient. Then, of course, is the operator efficiency. An experienced operator and an not so experienced operator, there could be variations in the quality of the results, and of course the local practices. the number of turns of rope on the cat head, it is recommended to have 2 turns, but if you are going to use less or more, it could make a difference. Also, the kind of rope which is used, the manila rope is recommended. People use wire ropes also. So that could change the amount of friction. And of course, the anvil, what is the weight of the anvil, how much energy it is transferring through the anvil, the type of hammers, whether it's a donut hammer or a trip hammer or a safety hammer, and the kind of maintenance which is done, the rod type, if you were to use A or AW rods or some non-standard rods, it could make a lot of difference. Of course, the soil type and depth at which you conduct the test, the verticality of the test, the number of blows per minute also has a impact on the SPT value. So we have to be careful to use the right kind of approach to get the right SPT values. So the SPT blow counts do not represent any simple physical property of the soil, but they can be correlated to the properties of interest. Various correlations are available, and these have been published by various authors in different forums, in different publications, and also these correlations are available in different national codes. But all these correlations are approximate and are not universally applicable. Despite all this, the correlations are used and are popular, particularly in weak soils, soft clays, loose sands, etc. The data is not exact and less reliable, especially when the N values are low, because you cannot measure a fraction of the N value, you measure it in whole numbers. So if your sampler penetrates more than 30 centimeter in a single blow or 2 blows, then you don't know whether what kind of a number should be taken. In loose sands, driving disturbance could affect the blow count. That means that the vibration could cause a little densification of loose sands. And also, if there is improper borehole cleaning, you will get wrong results. So there are different countries have different codes. Of course, ASTM and British code, these are the most popular codes. India uses IS 2131, as you're aware. There is an Australian code, Brazilian code, Chinese code, many others. Most other countries use ASTM. Turkey has its own code. So we need to be aware that, what kind of there are some usually very consistent in what to do. So let us see what are the commonly used correlations. The static properties are the relative density and void ratio, angle of internal friction of sand, undrained shear strength of clays. So you use it for bearing capacity and settlement analysis, pile capacities, even dynamic properties like shear modulus, shear wave velocity, and all. These have been correlated with N value. Of course, you should compare that results with the seismic tests. Liquefaction potential, it is usually done using the N value. So these are the correlations which are popularly used. It's 0 to 4 SPT value is very loose, then 5 to 10 is loose, 11 to 30 is medium dense, 31 to 50 is dense, and then very dense. Similarly, there are some density correlations also. So Bowles has given some correlations. Again, his correlation is based on N70. This has to be corrected to N60. So for different density conditions. So he is given various parameters here for phi, gamma, etc. Similarly, undrained shear strength of clays, you have very soft, medium, very stiff, and hard. E values are correlated with N, also correlated with CPT. So IS code gives a correlation of phi value with N. Of course, this graph again is misused without understanding for what it is applicable, but the IS code does give this. The main output, as you know, is SPT field N values. Let us try to understand why should we correct them. The N value has to be corrected to eliminate the human error while conducting SPT. Now, you also have to correct for overburden pressure, dye latency, the hammer efficiency, borehole diameter could affect the N value, sampler type, rod length, fines content, etc. So variation has been observed in the N values while using SPT different equipment and different field crew at the same location. So the hammer efficiency should be measured, and the SPT N value number has to be normalized to an energy efficiency of 60% to ensure that the SPT hammer does not affect the interpreted soil property. So this resulting number is called N60. So this N60 value may be used for liquefaction potential. And also correlating with phi, that is has to be done in a very planned way. Let us see what were the attempts to standardize the SPT. Since the test is cheap and easy to use, attempts to replace with other tests such as CPT, pressure meter tests, dialtometer, etc., have met with limited success. These other tests have been successfully used, but not supplement SPT or as a replacement. The first attempt to improve the quality of SPT data includes use of automatic trip hammer, reduce the friction losses between the rope and the pulley, and use only 2 turns of rope on the cat head. The use of automatic trip hammer was introduced in US and Europe in the late 80s and has been gaining popularity in India since the last 15 years or so. So this is a SPT automatic trip hammer. You can see this is used to lift the hammer and drop it from a fixed height. So So this, as you can see in that video, that fixed height is maintained with the automatic trip system. A very simple system. This is, of course, the disturbed sample collected from the SPT. Now I move on to energy measurement. Several different types of SPT hammers are used in the industry. There are various varying efficiencies influence the N value. Non-standard SPT systems may deliver highly variable energies. Therefore, if the energy transfer is erratic, the measured N value will not be realistic. Therefore, energy measurement improves the reliability of the soil strength estimates for geotechnical applications. What is the need for energy calibration? It is required to normalize the energy transfer to the SPT sampler with a and it will remove the scatter in the values, thus enhance the reliability of the data. So the calibration should be done for each rig for different type of driving systems and arrangements, different skill level of operator, and the type of hammer, whether it's an automatic grip hammer or a hydraulically operated hammer or a machine operated hammer. And then the N values should be standardized to 60% energy transfer. You can presume that most of the correlations will remain valid if you do that. So IS 189 to IS 1893 and of course 2131, all these shall be similar while addressing the specifications and the corrections. So the measured N value is normalized by multiplying by the ratio between the measured energy transfer to the rod, 60% of the theoretical potential energy. The normalization compensates for the variability of the efficiencies of the different SPT hammers. The soil strength, safe bearing pressure, foundation settlement, and other geotechnical parameters, then you can estimate based on the normalized corrected average N values. As you know, understand, low energy transfer will yield high N value, leading to unsafe predictions. High energy transfer could result in over-design. So you obtain normalized N60 for a reliable foundation analysis. Then liquefaction potential, of course, again, you can estimate using the N60 value as given in IS 189. So this is just a flow chart showing you that if you were to use, assuming that the energy transfer is 60%, the properties you may result with incorrect SPT values. If you will correct to N60 based on the hammer efficiency, the reliability, the correctness of your values will be much more. So once you have this, it becomes very easy to cross-check and get a reliable value of N. And there are some correlations available between phi and N60 also, which you may use. This is the equipment which is used for SPT analyzer. You can also use the PDA, the pile driving analyzer, which is used for high strain dynamic pile testing. So just another software has to be added to it. So what you have is an additional rod. I'm sorry. You have an additional rod. So this is an AW rod, which has been instrumented. It has 2 strain gauges and 2 accelerometers fixed on it. So it is introduced here in between the anvil and the hammer. So the SPT analyzer is furnished with a 0.6 meter long sub-assembly of an SPT rod, which is instrumented with 2 calibrated strain gauges. On one side, 2 accelerometers are bolted to the rod section. The instrumented section is then inserted here in so you have below the anvil, you have this instrumented rod, and then you can connect your these sensors to the SPT analyzer computer. So smart sensing allows SPT analyzer to read the rod instrumentation, obtaining sensor calibrations and rod sectional area. These quantities are input into the SPT analyzer automatically. This significantly simplifies the initial setup. So this is the basic setup here. The strain gauges and accelerometers obtain the force and velocity signals necessary for calculation of the energy transferred for each hammer blow. the energy is displayed on the screen. So the output that you get, you can store it on a, you can transfer it to the or your computer and do the analysis. And it has a, the software has a report creation option that is quick and easy to summarize. It gives you force and velocity, energy measurement, displacement, etc. versus time. And then for each data set, you can get, so if you measure for 3 or 4 blows, it gives you automatically the average and the variations, standard deviation, etc. So this method is already standardized as per the requirements of ASTM code. Of course, as I told you, the Indian code is also being updated. So just, sorry. All video showing the instrumented rod, and this cable is being connected to the SPT analyzer system for recording the. So this is the results of, you get a force and velocity signal, which you would then integrate and then work out the various factors. Basically, the energy, you have to integrate the force and velocity. So what we, you get here, this ETR is the energy transfer ratio. So you can see here that for different at different depths, what we were getting was a minor variations, but the average happened to be 82%. So an SPT value of 5 gets corrected to 6.8, and the value of 20 is actually 27. So, so this is the flow chart of the SPT, the field. You have the field, you calculate the N60 corrected value for, then according to the, I have to apply the overburden pressure correction, and also fine sands and silt below water table with N value greater than 15. You use the dilatancy correction to get the thing. Of course, for cohesive soils, you don't apply these corrections. So the energy correction factor, if you will look at IS 1893, it gives you various multiplying factors. So the CHT, which is given in the IS 1893, is the energy correction. If you don't apply the energy correction, it gives you a way of assuming how much it could be, but of course, that would not be realistic. So as you know, for hammer type, for a donut and pulley hammer, it says use 0.75, and with auto trip hammer, 1.33, assuming 80% energy transfer. So again, for weight of fall, there are factors here, and different kinds of samplers with liner, without liner, there are some multiplying factors. And then for diameter of the borehole, normally 150 mm diameter holes are used. So here you would use 150, 1.05, and again for the rod. This is the IS 2131 correction for overburden pressure. And fines content, this correlation is taken from IS 1893. So IS 2131 gives you these recommendations here. Here it talks about a blow count of 30 to 40 blows per minute. and the weight is 63.5, and the drop height 762 mm is exactly what is mentioned here. And of course, the non-standard hammer, this whatever is given in IS 1893, you can see for the different non-standard hammers. So you have donut hammer and with auto trip. So finally, basically what you are doing here is that the potential energy mgh equal to mv square by 2. So if you actually measure the velocity at impact, so then you can correlate with the and find out the energy transfer. So actual energy transfer divided by the potential energy, this is the energy transfer ratio or the ETR. So if your hammer efficiency happens to be 40% only, then and you measure an SPT value of say 7, you are calculating a SBC at a particular site of 75 kPa. And if it was actually 60%, then you would calculate this would become a blow count of 10. You calculate 100 kPa, whereas the energy was measured to be 80%, and you correct that to 13. You are coming at the SBC value of 150. So you can see how much variation there could be in the final SBC values if you were going for you're optimizing your design by measuring the energy. So I come to the revisions proposed in IS 2131. IGS has proposed certain changes, including SPT measurement. After a lot of deliberations and discussions and suggestions from leading practitioners and academicians from India and abroad, BIS has now finalized the revision in the code, and this is going to be shortly circulated, and hopefully it will be adopted soon. So the revisions include measurement of energy to normalize to 60%. The drive weight assembly shall consist of a driving a head with the weight is 63.5 kg, and the height of fall is corrected from 75 to 76 because all international standards specify 760 mm. So energy ensure that energy of the falling height is not reduced by friction between the drive weight and the guide rods. So to ensure a free fall of the hammer from the specified height, it is preferable to use a auto trip mechanism. The need for auto trip mechanism has now been introduced in the code. So you can use a mechanically or hydraulically operated auto trip system. Even the engine powered automatic hammer is being used in some cases. So energy transfer is proposed to be optional presently, and the idea is that first of all, the industry should, get familiar with the system, and then it can be made mandatory. So you have to use an instrumented rod, as I showed you. These you have two strain gauges and two accelerometers. And once you record this, you analyze the data and determine the force and velocity, calculate the ETR value. So now correct your N values to standard energy level of 60%. To do this, it is necessary to measure the energy input. So once you have done that, you can use it, apply it for the it is advisable that on important projects, do the measurement and use the site-specific energy corrections to the SPT values. So each measurement typically consists of monitoring the force and acceleration, time histories. So the recorded waves can be analyzed to calculate the energy transfer. So this is called the force. It is based on the force and velocity integration. So this is called the FV method. Instrumentation is used to record the response of the rods and must be the rods should be capable of withstanding accelerations of the order of 5,000 to 15,000 G and must respond sufficiently to the to record the details of the energy transfer, typically in 10 milliseconds. So instrumentation has to be extremely robust and responsive, and the response must also be repeatable over a large number of blows monitored at a site investigation. It is advisable to do such measurements for each set of rig, hammer, and operator combination at least once a year, or after major repairs are undertaken. This means that for each rig, if you were to change for a particular rig, if you were to change the hammer, you should calibrate it. If your operator changes, again, you should calibrate it. And of course, if any major repairs are undertaken, then you should again calibrate. Otherwise, you can do it once a year. One set of measurements should be considered as an average of 3 measurements on 3 SPT recordings at different depths, preferably at depths greater than 10 meters. So if the energy transfer is less than 40%, the system is considered too inefficient. It is advisable to modify, repair the system to improve the energy transfer. So Annexure B of ISO 22476, this has been included with suitable modifications in IS 2131. Presently, this is proposed as optional. After the industry implements it and it becomes popular, it can, of course, be made mandatory. Other revision which is proposed is that in case of hard strata such as weathered rock, hard laterite, very dense alluvium or boulders, the test may be terminated if the penetration for 25 blows is less than 5 centimeters, or if the rebound of the rods or hammer is observed, so as to avoid damage of it. If the shoe of the split spoon gets damaged or crumpled, it should be replaced with a new shoe. Use of damaged shoe is not permitted. So now I am going to illustrate 2 case studies. This one is a food processing plant in Noida. So this is the layout plan of the project. So these circular ones are the boreholes, which I am going to concentrate here upon. This is the typical borehole data. You can see the measured SPT values. These are the what it was conventionally field end values measured. Then we did some energy measurement records. It showed energy transfer of 77.9%. So the measurements, as you can see, 7.3, 10, 13.5, and 14.9. So these are the blow counts. And these were the SPT values at that particular depth. We plotted the energy transfer ratio versus depth and the displacement observed. So this is the energy transferred. This is for borehole 1 and this is for borehole 2. You can see this red graph. This is what was the field SPT value measured. And the blue graph is after correction for energy transfer. So you can see that there is substantial increase in the SPT value here. The higher N values meant that higher SBC value can be used. The design is more reliable because it is based on a standardized N value. So the need for pile foundations could be eliminated. This resulted in substantial cost savings. Also, there was a 12 to 15% increase in the safe SBC values. So foundation sizes could be reduced, and there was a 12% saving in the cost of isolated foundations. The second case study, this is in district Muzaffarpur in Bihar. So this is the layout plan of this industrial facility. So here we have again the typical borehole values. You can see top layer, the N values are quite loose, and then even in the sand layer, the N values are not very appreciable, less than 15 to nearly about 10-12 meter depth. So liquefaction analysis was done for the site. The design earthquake zone was taken as it was zone 4, and the earthquake magnitude 6.7 and PGA of 0.24 G. So design water table was at the ground level. So the SPT was, of course, an automatic trip hammer, and the assumed hammer efficiency was 60%. That was before the energy transfer measurements were done. So this is the results of the liquefaction analysis. As you can see here, the sand stratum is liquefiable 10 to 13.5 meter depth. The average depth of liquefaction is 12 meters in the sand stratum. So obviously this means that you have to take the piles to about 18-20 meters below the ground to get the necessary pile capacities. So the plan was that ground improvement could be done by installing stone columns to about 12-13 meter depth, or you go for piles extending to 22 to 25 meter depth. Now, to reconfirm this liquefaction potential, SPT measurement, energy measurement was done. So this is the corrected SPT values for an ETR of 75%. So you can see how the N values actually increased in the sand layer. So 75% energy transfer, liquefaction analysis showed no liquefaction, factor of safety greater than 1. So this resulted in a huge saving, since cost of was saved in the ground improvement, pile foundations, all this was not required. So isolated foundations with connecting beams and raft foundations for heavily loaded facilities were provided. The saving in the foundation cost was to the tune of 10 to 12 crores. So spending a small amount of money in measuring the energy transfer, you can see how much saving could be obtained in the foundation cost. So with this, I come to the end of this presentation. Normalizing the energy transfer during SPT can help standardizing the data. It can make interpretations more uniform and independent of the equipment and operator skill. So energy calibration should be made for each rig, which will have different type of driving system and different skill level of the operator using the trip hammer. So monitoring is usually done for 3 to 4 sets of readings to assess the scatter and get an average ETR value. Then you standardize it to 60%, and we presume that most of the correlations shall still be valid at N60. Then, of course, IGS 2131, 1892, 1893, all of them shall be similar while addressing specifications and correlations. Thank you very much. I shall be very happy to interact with you and take questions. very grateful to IIT Indore student chapter for requesting me to deliver this presentation. Thank you.
So thank you so much, sir. I think we have a question in the chat box. I think you can open also there. From Mr. Sunil Kumar.
Let me see if I can open.
Yeah, if you want, I'll read that. Is it
Please,
better
please.
to use straight SPT for our parameters and analysis rather than NGO, N60, sorry?
Is it better to use straight SPT for our parameters and analysis rather than N60? I would say that you should use N60 because it gives you the right standardized SPT value. As I had shown in some of these case studies, you can, get advantage in the SBC values, even liquefaction analysis. So I would strongly recommend that use N60 rather than the standard whatever SPT value you have got from the test. Unless, of course, you are very confident that you have done a brilliant job and ensured that the energy transfer is exactly 60%. I don't know how would you do that, but otherwise, the conventional method of using SPT value only is erroneous, as I would say.
We have the second question from Sunil only. So what is the maximum SPT can be obtained in soil?
That's a tough one. You could get in loose to very soils, even 1 or 2, and dense sands, dense soils, you could get more than 50, even greater than 100. I have seen in cemented sands and cemented soils and very dense, very hard clays. But what is the maximum energy transfer? If you ask, it would depend on the equipment. There have been instances where the energy transfer has been more than 90% also, particularly if you are using those engine operated systems with a hydraulic hammer, which really gives you a good correlation.
So other participants, if you have any questions, you can just unmute yourself and then ask. And we have SK Prasad sir also joined. Sir, good morning.
Very good morning. Very good morning. It is nice to listen to Professor Dr. Ravi Sundaram.
Thank you, Dr. Prasad. Thank you, Professor Prasad, for joining this presentation.
Very nice.
I'm great.
I enjoyed your lecture. Very good, very useful, and very apt, on time.
Yeah, actually, SPT energy correction now we have been doing on several projects, and everywhere we are actually amazed at the kind of benefits that you can get if you can measure the SPT values, the energy transfer.
I know. Yeah.
Particularly in sites which are prone to liquefaction, the entire foundation cost depends on the depth of liquefaction. So instead of struggling with a system where if it shows particularly 10 to 12 meters of liquefaction, in some cases I have seen even 15 meters liquefaction. If you can optimize that depth of liquefaction, the tremendous savings in the foundation cost. So what you actually save in the foundation costs, in compared to that, this additional cost of testing is really insignificant.
You're correct. If, let us say, the depth of liquefaction is very deep, more than 15 meters, and if the structure is not very, very important, what is your suggestion?
Well, take a risk and build it, hope that there won't be any earthquake. Like people do it in case of a boundary wall construction. Suppose you have a site main building, they will go for ground improvement or piles and all that. But when you come to a boundary wall,
Yeah.
Doing ground improvement to 15 meters would be ridiculous, or even using 20-meter long pipe. So what they say is that, fine, let us make a lightweight boundary wall, and suppose a major earthquake strikes, we will rebuild the boundary wall. It's cheaper than putting so much money into the construction of the boundary wall.
That's right. That's right.
Mm.
No, but again, boundary wall, it will be useful if the liquefaction is at shallow depths. But at very deep elevations, I don't know. I don't think it's going to make any significance.
You see,
If the depth of liquefaction is shallow, what you said is correct. You can confine, put a boundary wall or confinement, which is acceptable.
Yeah, you're right. Because you see, if there is a clay layer on top and a sand layer below, the clay does not liquefy and the sand will liquefy.
Correct.
So my boundary wall stresses are not going down into the sand.
Exactly.
We are fine. But
Exactly.
suppose the sand is right from the ground surface.
Yeah. Then your confinement boundary wall plays a significant role.
Yeah, and also if the groundwater is very shallow, see, these are the two factors which affect. So if the groundwater is, say, at 8 or 9 meter depth, the normal tendency of most designers is to assume that the groundwater will rise by about 4 or 5 meters, and then do the analysis.
Yeah.
But whether that actually happens or not, it's all your luck.
You're right. You're right.
When if the earthquake strikes when the water table has risen, then you are more critical. In peak summers, when the groundwater is actually down, that time if the earthquake strikes. But we have seen what happened in Turkey recently. So not worth taking all that risk,
Correct. So did you analyze anything about Turkey earthquake? Were there liquefaction problems?
No, I don't have any data about Turkey. All only what you read in the newspapers is all that I.
Yeah, same with me. I didn't have any detail about geotechnical problems, except some of the faults and some failures, foundation failures. Yeah, it would be interesting if some of us, some Indians, go and make some analysis there.
Sir, as far as the Bhuj earthquake is concerned, a lot of people had done a lot of work. What findings they've been published in various forums.
Correct.
In India, at least that has been the biggest earthquake in the.
Yeah, that was an eye opener actually.
Yes.
See, whatever, there were so many agencies which got attracted, and lot of research went on.
Yes.
2001. Yes, you are very right. I
Now,
always wish.
okay.
Yeah, I just wish some team of India should go outside globally, wherever there are some problems, not just earthquake, and make a study of its own. So this is where IGS can be a leader. So I wish something like that happens. Nilima can probably, Professor Nilima can answer that. I strongly believe, a team from India should go to places where there have been geotechnical problems and some investigation, and preparing our own report. So that makes us more authentic, more global.
Actually, there are so many local experts everywhere. But if data can be shared, and you can't sit in a foreign country for years together and do research just like that. If data can be shared and joint research can be done, that will really be something which
it will be useful, right?
Beneficial. Like now the friendship with Nepal, IGS has connected. So Nepal also has a lot of geotechnical problem, not necessarily liquefaction. It is hill slope stability and so many other things.
Correct, correct.
So if
I
researchers in
think that
Nepal,
Geomandu was a very good thing that what Dr. Anil and Dr. AP has done this.
Yeah,
a
I was
great
very happy.
interaction.
All of you went as a team. I really appreciate.
Yeah. Of course, it's all started with Dr. Anil's initiation. So,
Good.
sir, we have a couple
actually,
of
Dr.
questions in the
Samadia,
chat box.
Dr. Samadia had initiated it, and then it's great that it happened. In case there is no underground water, but the soil is sandy, having
Sir, Govind
liquefaction.
Pachani, sir, who wrote this question, he is a chief engineer at RRCAT in Indore. Very senior, and he has done a lot of things for RRCAT, for their foundations and that.
All right. Sir, what I will say is that if the water from external sources is a permanent phenomenon, and it has seeped through the soils to substantial depth, then there is probably a possibility that it can trigger liquefaction. But if it is just a surface feature, and maybe top 1 or 2 feet is saturated because of the water, then it will not probably cause liquefaction.
I think we have one more question in the above. From Sidhuram.
Sir, if this is inexpensive test, even though most of the soil investigation agencies were using rope dropping methods instead of auto trip hammer technique, how important the agencies need to shift to auto trip hammer to, you see, the whole purpose which I have taken it on myself is that we need to make awareness that replace the conventional rope dropping method with an automatic trip hammer. The system which I showed you here is just a small modification, doesn't cost too much, and you can get an auto trip. And of course, if you were to measure the energy, then you have really done it. See, the whole purpose is that with important projects coming on the, now we are designing multi-story buildings, 50 stories, 60 stories, and even taller. Huge power plants, thermal power plants, solar power plants, so many other complex structures which were not being done earlier are now being done. Lands which were not considered buildable in the past, we are now constructing on those kinds of soils. So what is important? Power plants, refineries, various other industrial facilities, heavily loaded facilities. Now, if you were to, improve the quality of your data acquisition, your foundation system will improve. You can economize on the foundation system. You will be able to get a more reliable foundation. You will have lesser failures. So these are all the long-term benefits. So I think we should encourage all the investigation agencies to move from the conventional rope and pulley system to a more efficient system, so that the quality of geotechnical investigation in the country can improve as a whole.
Now, Mr. Ravi Sundaram, you made a excellent presentation, and
Thank you,
your comment on this improving the quality of SPT tests that we do is very well taken. But since I was in Kanpur and we mainly dealt with silty soils, and SPT we found is more reliable for sands and some corrections. But my main concern was with the correlations that we have with SPT values. And should we always use that, or should we go for good quality boring, collecting undisturbed samples, and then rely more on the laboratory test data? So that's my question. So we always relied more heavily on the laboratory test data that we got from a good quality undisturbed sample.
So to this
So
question,
what is
I
your
would
comment on that?
see at every stage you need quality, whether it is the field work, whether it is the lab data, whether it is the kind of analysis that you do. At every stage you need good quality. So this is stage one. You go and do a borehole. You do an SPT. You collect an undisturbed sample. So if we were to consider this as stage one, so I need to be getting the right values of SPT. I need to get undisturbed samples should be as undisturbed as possible with minimum disturbance that is feasible. Uh, and then, of course, the proper laboratory testing. And of course, you are an expert on the analysis of the data. But in addition to SPT, there are various other tests also which need to be, SPT is not all. Now, the greater emphasis in the current scenario, particularly in silts, as you just said, is the CPT. Uh, uh, Electric cone penetration tests have become quite popular now, and we have been using CPT and finding very good results in both sands and silts. And the correlations of QC with various geotechnical parameters, they are much superior to the what you get from SPT. The other kind of test which is now becoming, has been used in the country for the last 10, 15 years is the pressure meter test.
Right.
Pressure meter test, of course, it is a little bit more expensive. But the reason why it is expensive is because that very few agencies are aware of the test, and they don't get it done on their projects. So obviously, it's a matter of volumes. If more agencies will, if pressure meter test could become more popular, the cost will automatically go down. This electric cone penetration test, piezo cone, seismic cone, all these are, the awareness is increasing, and you have to use it in conjunction with your borehole, SPT, undisturbed sampling, laboratory testing. CPT gives you much better correlations than lab tests. However,
Exactly.
top quality lab test you may be doing, the quality of the undisturbed sample, you can never get it 100%. So
No,
therefore,
I agree with you, but unfortunately, many of the people still think that there's nothing beyond SPT. And most, I'm trying to convince people that don't rely too much on SPT for, earthquake potentials and things like that.
go for CPT. CPT is much
CPT is
better.
better, or even do dynamic traction testing and get CRR values and things like that, and then use other analytical methods, and then get that, but
Dynamic
just
triaxial
thinking
testing,
that
of course, I will agree with you, but the number of agencies doing dynamic triaxial testing is limited. So
very
usually
limited.
in research institutions only.
Right. So
We need to popularize the test so that geotechnical investigation agencies get the equipment and they start doing the test.
exactly, yeah, so that is what should be the
recently on one project, we had to do some triaxial test, cyclic triaxial tests and other tests. We found that ISC Bangalore or IIT Roorkee and one or two other institutions were the only ones which had the kind of test systems which can do the test. And obviously, if we are going to talk about designing, hundreds of bridges and various other tall multi-story buildings in different parts of the country, there has been quite a bit of push on infrastructure by the government. And if you were to rely on these research institutions, none of those projects can ever come up.
You're right. I think we should have more facilities created for that.
Of course, one to facilities created, and whatever facilities are available, they should be efficiently used.
Yes.
And triaxial testing needs a lot of expertise, whereas CPT testing doesn't require that level of expertise.
Yeah.
So, of course, SPT energy, which I told you again, and with a little bit of training, routine site supervisor can do it. Same thing with CPT. So I don't want a scenario where people have this fancy lab equipment. They don't know how to do the test, randomly do it the way they think is to be done and generate some results which don't make sense.
No, I agree with you, but if they can also do CPT, and then at least we have two options to predict liquefaction potential.
Yes.
So that'd be better, rather than relying too heavily on one particular test.
In fact, I was talking to somebody who was telling me about, getting undisturbed samples in sand by ground freezing technique.
Yes.
You can do that, but where is the technology available for if I have to do a test, say in Bihar, and I have to bring the sample to either Kanpur or Delhi or anywhere else to do the test. How is it possible to transport a frozen sample and how to defrost the sample without damaging the structure of the soil? All those things are very complex.
Right. I agree with you.
Professor Sarvesh Chandra, good morning. SK Prasad here.
Yeah, how are you, Dr. Prasad? Yeah.
So nice. Meeting you online, of course.
Yeah.
Sir, I think we have one more question in the chat box.
Considering the overburden, eliminating the overburden pressures. I don't understand this question.
So there is a follow-up question just about that.
Sorry, is there any other options other than SPT to get results at 10 meter? There are similar literature. DCPT, I will not suggest. I will suggest SCPT, static cone penetration test. Piezo cone is the right approach. It is much superior to SPT. So that's what I have to say, that DCP, there are some literature relating SPT to a DCPT, but the correlations have to be developed site specific. There is not sufficient data available to have a universal correlation. But strongly I would recommend using a piezo cone measuring the cone tip resistance, frictional resistance, and pore water pressure. You have some very efficient correlations which are available between CPT data and various engineering properties, and very reliable. I hope Mr. Vamsi.
Sir, I think we are done with the questions, I guess. So thank you so much. I'll share your email ID with the participants or otherwise. It is available. You can also refer. Okay, if you type Sanjay's Ravi Sundaram surname, you will get the email ID as well. So thank you so much. So I request Kunal to take over. Kunal.
Okay. Good morning, everyone. I would like to deliver the vote of thanks for Mr. Ravi Sundaram sir. We want to extend our sincere thanks for the knowledge that you have shared today. Your lecture was insightful and engaging and kept us all attentive all the way. Your expertise has truly inspired us to learn more and explore the subject further. We appreciate the time and effort you have put to make this session a great success. Thank you so much, sir. Thank you so much for joining.
Thank you very much.
Thank
I'm
you so
greatly
much,
honored.
everyone. Thank you, sir. And thanks
You're
for
most welcome.
joining.
I'm greatly honored that all of you have taken your time out to listen to me. Thank you again.
Thank you so much. Thanks to everyone. And please subscribe to this Facebook and YouTube because a lot of activities are coming, especially this year. I think, it will be helpful for you to get network and, at least like be interact and something like that. Thank you so much.
All
Thank
right.
you, sir.
Thank you.
So we are closing the session now. Thanks, everyone.
Thank you.